Hello, welcome. Let's try to solve another Leetcode problem. 1981, the difference between target and chosen elements. So the problem is easy to understand. We are just giving m times n integer matrix map and integer target. So for each of the row, we can choose one number, and we must choose one number in each of the row. And finally, we're going to return the minimum absolute difference. So for the first example, we can choose 1, 5, 7. So the difference is going to be the 1 plus 5 plus 7 is going to be 13. So the difference is going to be 0. And because we're going to return the minimum absolute difference, so it is okay. And for the second one, 1 plus 2 plus 3, it's going to be 6. And it must be 6 because at least we need to choose a number in each of the row. So 100 minus 6 is going to be 94. So this is also okay. And for this one, we're going to choose a number because the target is a 6, so we're going to choose a 7 instead of 8 or 2 because 7 minus 6 is going to be 1, and this is going to be the minimum. Yeah. So how can we choose this? How can we solve this problem? You might think maybe we're going to use brute force. So this is just the brute force idea. So we're going to prepare row and column, and we're going to prepare a final result. It's going to be infinity. Yeah. And then we just need to minimize this result. So here, let me just delete the case. Basically, we don't need to use case because this is just a brute force. So the idea is that if we go to the last row, so this is going to be the last row, and we're going to check the result. It can be the minimum of the result with absolute of t minus the target. So this t is accumulated sum and minus the target, and we're going to choose the absolute value. So this is okay. I hope everyone should think about this problem by using this kind of idea. But this is just a brute force. It can pass for some testing cases, but definitely it cannot pass all testing cases. Maybe let me just use some testing cases to prove it should work. Yeah, now as you can see, it passed some testing cases, but definitely it cannot pass all testing cases. And because this is a brute force, the time complexity is going to be something like 70 to the power of 70. And you should know that it's going to be a really, really big number because 70 to the power of 70 is going to be a really big number. Yeah, as you can see, while we are waiting, it didn't work because it got time limit exceeded. Yeah. Now we're going to understand the problem as a group knapsack problem. So the idea is that for each of the row, we're going to say it as a group. So for the second row, it's going to be another group, and for the third row, it's going to be the third group. So we're going to understand it as a set. Yeah. So for the first group, so what is the value for our set? It's going to be 1, 2, 3. Yeah. So that means if we only have one row, so what's going to be the possible result? It's going to be 1, 2, 3. And then we're going to use 1, 2, 3 compared with the target. For example, the target is 13. So if there's only one row, so the 13 minus 3, the final result is going to be 10. It's going to be the minimum. But now we have another row. Yeah. We need to combine the first row with the second row. How can we combine that? We're going to use 4 plus 1, 4 plus 2, 4 plus 3, and 5 plus 1, 5 plus 2, 5 plus 3, or 6 plus 1, 6 plus 2, and 6 plus 3. Maybe you're going to think this might be time limit exceeded as well, but it is not like that. Because you need to be careful with what we are giving, because the value inside the matrix is going to be limited to 70. So this is a very good example of a group knapsack. First of all, this knapsack is bounded. It means we have a capacity of this knapsack because for each of the value maximum, it's going to be 70. And how many rows and how many columns? Yeah. So we have 70 rows and 70 columns maximally. So this means for each of the row, we can choose a value. So for example, if we choose the maximum value for each of the rows, 70, 70, how many of them? It's going to be 70 times 70. Yeah. So what's going to be the final result? It's going to be 4900. Basically, this is not a big number. This is okay for our space. Yeah. So this means this problem is solvable. If we store, if we store 4900 values inside a set, basically for each of the row, we're gonna have 4,900 different values, and how many rows? It's going to be 70 rows. So in this way, the time complexity is going to be 70 to the power of 3. Basically, this is going to be a very small number. Instead of a 70 to the power of 70, it's going to be a really big number. But why this kind of a way? Why does it work? This is exactly like the group knapsack problem. Yeah, we're gonna use the group knapsack to solve the problem. So for the first row, for the first row, we're gonna understand it. It's gonna be the first group. Basically, we're gonna choose a value how many different ways. It's gonna be 1, 2, 3, and then if our group is 2, so what it's gonna be like? If a group is gonna be 2, it's gonna be something like 5 because 4 plus 1 and 4 plus 2. It's gonna be 6 and 7. And here 5 plus 1, 6 we have, 5 plus 2, 7 we have, and 5 plus 3 is going to be 8. And then we're going to start from 6 plus 1, 6 plus 2, and 6 plus 3 is going to be 9. So actually there are only 1, 2, 3, 4, 5 values instead of 9 values. And then we're going to go to the next. And finally we just enumerate all those values minus the target, and we're going to choose the minimum value. So this is the basic idea. Now we will use group knapsack to solve the problem. Yeah. Normally for the group knapsack, we can also use a set to solve the problem easily. So first of all, we're gonna prepare a class and we're gonna define the DFS. So here I'm gonna use f as the DFS. So inside I'm gonna start from each of the row. So if the row is equal to 0, this means it is the first row. So I'm going to directly return a set. So the set is going to be the mat 0. So for this example, if I only have one row, it's going to be 1, 2, 3. I have many rows, so I can directly return a set. So this set is going to be x plus y for x inside the current row. It's going to be mat I, and y gonna be the previous values. So for y inside f I minus 1. So this is gonna be all the possible results. Let's just use an example. If we only have 2 rows, it's gonna be something like this. So if we are going to calculate the second row, here this I gonna be 1. So f2 minus 1, row minus 1, gonna be f1. If I equal to 0, we didn't return, but here I equal to 1, it means x plus y. So x is inside the mat I, it's going to be 4, 5, and 6, and y going to be inside fi minus 1, it's going to be f0. So f0 going to be 1, 2, 3. So the combinations with the 4, 1, 4, 2, 4, 3, 5, 1, 5, 2, 5, 3, and 6, 1, 6, 2, and 6, 3, it's going to be something like 5 to 9. This is going to all the possible result. And then we're going to combine with the next row. So 7, 8, 9 combine with 5 to 9. Definitely there's a value 5 plus 8 is going to be 13. 13 minus 13 is going to be 0. So we're going to return this is 0. Yeah. Now let's just return the final result. It's going to be the minimum value. Yeah, it's going to be the minimum of the absolute value. So we're going to use absolute target minus this v, and for v inside f, here I'm going to use r minus 1, and this r going to be how many rows? It's going to be length of the matrix. Yeah. So this is the group knapsack solution, but we're going to use a set because this set is much easier to write and much easier to understand. Yeah. Now let me just submit it to check if it works. Now as you can see it works, although it is like 5 seconds, but it is okay. Because basically for this problem the time complexity gonna be 70 to the power of 3, because this I, how many rows, it's gonna be 70. And for the set, and inside of the set, what is the maximum set? It's gonna be 70 times 70. So it's gonna be like yeah, let me just check. So 70, it means 7 to the power of 3 times 10 to the power of 3. So basically 7 to the power of 3, 10 to the power of 3. So this value is going to be less than 10 to the power of 6. So this is why we can pass. But why it is slow? Because we are using a set. For the set calculation, it's going to be really slow. But I think this is okay for understanding the group knapsack problem. basically, if we cannot solve it by using the brute force, because if it is like brute force, definitely it cannot be 70. Maybe there are only 7 rows and 7 columns. Maybe this is okay, 7 to the power of 7, but definitely 70 to the power of 70, definitely it didn't work. So we're gonna understand the problem by control the space. If the space is limited, it's gonna be a group knapsack. So the space gonna be 4900. So this gonna be all the possible values, and then we just need to check what kind of values we have if we choose for all the numbers in each of the row, and we just compare with the target. Yeah. I think that's all about this problem. Thank you for watching. See you next time.